Whoa, I missed something.
I think that's what we got. Yeah, page 10. That's what I'm showing.
My fucking date's wrong.
Alright, so this is also like a review from last year. So you remember, if we have that imaginary unit, it is I, lowercase I, and, it's basically what happens when we try to take the square root of a negative, and we would separate that, make it a -1, which we'll kind of talk about as we get there. And there, so there's what's called pure imaginary, BI, where B is just some coefficient, basically, some constant that is there. So I is really what we're talking about, but it's when there's no addition or subtraction, it's just a coefficient and I. Alright, so when we have this, just gonna go back through this from last year, we would separate this, this kinda would look like this, the square root of -1, the square root of 144, which we're not really gonna do it this way, but I'm just gonna show it super basic right now. So, when we take the square root of -1, we really can't do it in the real number system, that's where we come into imaginary numbers. So the square root of -1 is just I. Okay there? Square root of 144 is 12, so we put it together and we have 12I. Now, if I was doing this ordinarily, Lily, you were probably one to get that. If we were doing this ordinarily, what I would do when I split this, like I know if I was taking positive 80 and I was taking the square root of positive 80, it would be 16 times 5, because 16 is my perfect square. Y'all okay there? Yes? Okay. So when I separate that like that, I'm gonna put the negative with the part that's coming out. Does that make sense? So when I pull that out, the square root of -16 is 4I. Because the negative is the I and the 16 is the 4. I'm just not gonna write that separately every time, I'm just gonna put it over here. So we would have 4I square root of 5. Y'all okay there? Alright, so this would be the same way. I mean, 36 and 121 are both perfect squares. So that would be 6 over 11. That negative underneath that radical is gonna give you an I. So that would normally be written either one of two ways. It would look like this, 6I over 11, or 6 over 11I. You just have to be careful on this back one right here, that the I does not look like it's under the fraction bar. Does that make sense? Because we can't have I in the denominator, and that's a whole other thing we'll talk about in a minute. Y'all okay with that so far? Yes, okay. Alright, so those powers of I gave them to you last year, I'm gonna give them to you again. So the first one, you're out of the first, square root of -1 is just I. Then so I squared would basically be the square root of -1 squared, which is just -1. Then to the third would basically be this times this. Does that make sense? I mean, in reality, that's what it would be. So this, we know, becomes -1, and this becomes I, so it's basically I times -1, which is just -I. And then this one would be, out of the fourth can be I squared, which would be -1 times -1, which is just 1. And those patterns are gonna continue. Okay, so like, when I get to the 5th, I'm I. When I get to the 6th, -1. To the 7th, -I. And to the 8th, +1. So it's I1, I1, I1. You just have to know the signs, and it alternates. Y'all remember doing that last year? Okay. So if you can memorize, if you can learn these right here, we can do everything else from there. Which is what I told y'all to do last year. So if I had I to the 11, so essentially what I'm doing is I'm looking at kind of going through a series of 4, right? So if I think about to the 4th power, multiples of 4 would be 4, 8, 12, 16. Y'all see what I'm saying? Okay, so 12, I to the 12th is gonna be 1, right? Yes? So if I to the 12 is equal to 1, then I to the 11 would be back one step, it has to be negative I. I just go back a step. So I'm gonna find one that's close that I usually use the 4, it's easy for me. And then I go forward or backwards from there. If I go into 8, I would say, okay, I to the 8th is 1, and then 11 is 3 more, so then I would be at 1, 1, 2, 3, and it would still get me there. Does that make sense to y'all? Y'all remember doing that last year?
Why does the negative just drop off?
Because of this right here, this pattern, because you're multiplying negatives and positives together. You do notice that the third, it's this power right here is a negative I.
Yeah, but why did the, like, I, negative 11, why did
Okay, because you just follow the pattern, Zane, unless you wanna sit here and write this out over and over and over for every single one of them.
No, no.
Okay, then learn the pattern. Because otherwise, that's what you have to do. Is you have to be like, okay, this, like, and keep going until you get to the right one. 11 times. Well, some of those are like out of the 56. Do you wanna do that, 56 times?
No.
Okay, so learn the pattern. So if you'll learn the pattern, then you can count from there. Does that make sense? Because the reason that happens is it has to do with multiplying this square, this right here, times this one right here. And we do it in a repeated pattern over and over and over and over. I just am not gonna write that out over and over and over because you don't need to, because you can follow the pattern. We okay there? So it's gonna be I1, I1. I1 is gonna alternate, does that make sense? And the sign is also gonna flip. Are y'all okay there? Okay. So learn this, if you'll just learn the first 4, you don't have to learn any of the others, because we'll go from there. Alright, so this one, the negative 3, I'm just gonna write it out here. Alright? I'll come back and get that in a minute. So I've got I to the 21, right? Alright, so do you wanna go backwards to 20? Like that would be easiest for me, that's what I would think, yes? Yeah. Okay, so I to the 20 is gonna fall right here, because 4 times 5 is 20, right? Okay, so I to the 20 is 1, which means I to the 21 jumps back up here, and it has to be I. So then when I put negative 3 and I together, I get negative 3I. That's the answer right there. That's all you have to do. You understand what I'm saying with the pattern? Go ahead.
Since 3 is a factor of 21, how come it wouldn't, or how come you couldn't just do like why couldn't it be negative I? You know what I mean?
Because it just doesn't work that way.
Okay.
Because here's the deal, the pattern isn't a 3-term pattern, it's a 4-term pattern.
Oh,
So it's every 4 times, that's why I use the 4.
okay.
Because a 3 won't work. Because if it was only 3 things and this wasn't part of the pattern, then you could do that. But we have to use the 4 because it takes all 4 things to complete the cycle. Does that make sense? So you have to follow the cycle. Alright, that's a valid question. Alright, so this one right here, so I've got negative 6. Alright, so I to the 13. Alright, well 12 would be right here, yes? Which means 13 is here, right? So that would be negative 6I. And we're multiplying that times, looks like 18. I to the 3rd. Well, 3rd's here, yes.
Where does the negative 6 come from?
Isn't it negative 6? Oh, it's not negative, sorry. It's positive 6. Sorry, I don't know why, I just decided it was negative. Sorry about that. Alright, so then I to the 3rd there would be a negative I. Or the same thing as negative 18I. Are y'all okay there? Alright, so then 6 times 18. And actually, there's probably another way we could have done that a little bit easier, but.
108.
Okay, so 6 times 18 is 108, and then I have I times a negative, you know what, let's not do it that way. I'm sorry. Sorry, my fault.
Are you gonna add the i's, like 13 plus 3?
Yeah, I think it's probably a little easier way to do it.
I was gonna ask if you can do that.
Yeah, when we're just straight that is easier to do. So we do like basically 6 times 18 times I to the, looks like we have 16 now. Because we multiply because you treat I like a variable, right? And we can add the powers. Okay, so then you said this was 108. and then out of the 16 is gonna fall right here to the 4,
No,
which is
no,
just,
1 by or 8.
it's just gonna be 1. Y'all okay there? Alright, so this one we can use that power rule, but remember this has to go in, so you really have 2 to the 5th, and then I to the 45 is what we got there. Does that make sense? Alright, so 2 to the 5th is 32, and then I to the 45, so if I go down 1, I'd be 44, which is obviously a multiple of 4. So then I would circle back around, it just gives me an I. So this is 32, and this is I. So we just have 32I as your answer. Y'all alright with these?
Yes, sir.
Okay,
Yes,
so
sir.
are y'all okay if I skip over these two, or do y'all want me to do them? It's up to y'all.
Do number 9.
Number 9, okay. Alright, so this I have, square root of -9 to the 3rd. So probably, I'm gonna go ahead and take this out of the radical and make it, 3I cubed. And then this is still 2I to the 6, so I'm gonna just leave that over there for right now. So when I do 3I cubed, 3 cubed is gonna be 27. I cubed, are y'all okay there?
Yes.
And then this is gonna be 2 to the 6th. 2 to the 6th is 64. So I'm gonna multiply that, 64, and this would be I to the 6th, which means I have a total of I to the 9. Are we okay there?
Wait, where'd you get the 64 again?
2 to the 6th.
Oh, okay.
Okay, so this would end up being 27 times 64, and then I to the 9. Are we alright that that's I to the 9? That we're dealing with I to the 9?
Yes, sir.
Alright, so if I go backwards 1 to 8, I'm at 1, which means I circle back around, which means I just have an I right there. Are we okay there? Alright, so now I need to multiply 27 times 64, so I can figure out where I got.
1,728.
Okay, 1,728, I goes back there at the back. Are y'all okay there? Alright. So let's take, okay, so now we have like the complex. So complex is when we have an imaginary and then a normal number or a regular number, okay? So, I mean, we're still gonna be using our rules. These are just additions, so this is just combined like terms. So when you're just combining like terms, we're just gonna treat I like any other variable, like we treat X, okay? Y'all okay there? So if I've got addition, I'm gonna deal with my constants as one and my variable term as the other. Does that make sense? So then I'd have 6 minus 8, which would be -2. -4 and 6 would be +2I, and that's it. Like, that's all you're doing right there. It's just adding and subtracting like terms. And in that case, you're treating it just like you would treat X or anything else. There's really not anything super wonky on the addition or subtraction. So I'm not gonna do 11. Are y'all okay if I skip over 11? Okay, so let me come down here and we'll look at this one where we have to multiply. So when we multiply this in, we distribute that in, that gives us -32I plus 20I squared. Okay, well remember, I squared, I can't leave a power of I. We always have to get rid of that power. I squared has a value of -1 from up above. So this is gonna end up being -20. Does that make sense? So I'm gonna write my -20 first, and then minus 32I. If I have a single I can leave it, but I cannot leave an I squared in my answer. Everybody okay there? Alright, so if we did this one, it's kinda the same thing. I'm gonna have 18 plus 12I, it's like minus 5I plus 7I squared. We have that same situation right there where that's gonna be a -1. Are we okay there? So basically, these two right here are gonna combine, and then my 18 and this -1 right here is gonna make that a -7. Are y'all okay that becomes -7?
Yes, sir.
So I'm gonna have 18 minus 7, which would be 11. And then 12 minus 5 would be 7, so plus 7I. Thank you, Rob. Y'all okay with that that one? I squared's the one you see the most often. Then we're gonna change it to a -1. And then we have to multiply it times the coefficient there. Y'all good so far?
Yes, sir.
Okay. Alright, this one right here, and it is pretty much just like what we did on that last one. This one's a difference of squares where the center is gonna cancel. Are y'all okay with that? That this is gonna cancel? Yes?
Yes,
You recognize that? Alright, so basically, since the center's gonna cancel, I'd have 25 minus 9i squared. I squared becomes a -1. So then that would be -1 times -9 would become +9. So I'd add them together and get a whole number 34. Okay, like when you have a difference of squares, a lot of times you'll come out with a whole number. Y'all okay there? This one is a perfect square trinomial. You need your study guide. Alright, y'all okay if I skip this one, or do y'all wanna do this one? Would y'all tell me what you wanna do?
We can skip it.
Huh?
Skip it.
Skip it, alright, let's go down, let's just look at 18. So these, I mean, cause you're just gonna, like, you're gonna have to write that twice, FOIL it. This, you're gonna FOIL it, distribute, combine like terms, do your stuff. So I think it'll be alright. Alright, here, since I have this I in the denominator, it's the same way like when I have a radical in the denominator, I'm not allowed to do that. So I have to rationalize it. So here, I'm just gonna multiply the numerator and the denominator by I. So in the top, I have 6i, and in the bottom, I get 7i squared, which becomes a -1. So -1 times 7 is -7. So I end up with -6i over 7. That's probably how I'd write it.
Wait, you said you want to get the I out of the denominator?
Yeah, you cannot have it in the denominator.
Oh, denominator.
Yes, you can't have it in the denominator, just like you can't have a radical. We okay? Alright, so this one's pretty much, I'm gonna do the same thing, as I'm gonna multiply the top and the bottom by I. And I could multiply by 8i, but what I'm doing is I'm making that have bigger numbers that I have to simplify later. So I'm not gonna use the 8, I'm just gonna multiply by the I, cause the 8's okay in the denominator, the I is the problem. Does that make sense? Okay, so that's gonna give me 26i plus 4i squared on top over 8i squared on the denominator. We okay there? So this becomes a -1 and this becomes a -1. We okay there? So that looks like a -4, and we're gonna write the constant first, -4 plus 2i
26.
over -8, what?
Isn't it?
It's
It's
26.
Oh,
It's
oh,
26.
sorry. 26, yeah, sorry. Forgot the wrong 6 there. Okay, so 26i, okay, so now I'm all right, now I'm okay, yeah. All right, which all of these can simplify by 2, is about the only thing that'll go in there. Yeah, I'm gonna divide everything by the -2, pull it out, so that's gonna give me 2 plus 13i over 4. Nope, minus 13i, sign change. Sorry. 2 minus 13i over 4. Y'all okay there? Y'all good? Everybody okay? Alright, so this one, I have a binomial denominator. What do I have to do when I have a binomial denominator? We did this yesterday with radicals.
Change the sign.
You gotta change the sign, yeah.
Yeah, we're multiplying by that conjugate, so it'd be 2 plus 6i, 2 plus 6i. So on the top, I just have to, distribute, so that looks like 2i plus 6i squared, which I'll deal with. And in the bottom, I'm gonna have 4. This is a difference of squares, the center's gonna cancel, right? So I'm gonna have minus 36I squared, which I'll have to change to the -1. We okay there? So then I have, so when I make this a -1 times 6, I'm gonna have -6 plus 2I on the top. And when I make that a -1, that's gonna be a positive 36, and 4 would be 40. No. Yeah, cause this is a -1.
Yes.
So a -1 times 30 times a -36 would be a positive 36 plus 4.
Yes.
Are we in agreement there? Okay, so 40, everything's divisible by 2. So, and if you wanted to divide by a -2, you could, it's really not gonna make a ton of difference there, I'm okay if that first number's negative, so that would give us -3 minus I over 20. You okay there? Plus I.
Yeah.
Sorry, I didn't take the negative, we could've, but we didn't have to. So that's just kind of a personal preference, I'm okay if your 3 is negative up front, it doesn't make any difference to me. Y'all okay there? It's really when both of those numerators are, and when they're all negative, or 2 of these are negative, it both be. Alright, so this one we do the same thing, we're gonna multiply times 1 plus 3I. So this time we'll have to FOIL out there, so it looks like I've got -5 minus 15I plus 5I plus 15I squared in the numerator. Y'all okay there? In the denominator, the middle's gonna cancel, so I'm gonna have 1 minus 9I squared. We good there? Alright, so I'll deal with those, so this I squared right out here, I know there's no lower ring there, that's a -1, right? So when I put that -1 with that 15, that's already positive, that's gonna be a -15, we okay there? Yes, so a -15, I've got this -5 out here, so that would be -20. And then my I's right here at the top, that's a -15, a positive 5, -10. Minus 10I, and then on the bottom, this I squared becomes a -1. So, which is means I'm gonna have 1 plus 9 instead of 1 minus 9, which gives me a 10, that works out nicely.
Divide everything by 10.
Yeah, divide everything by 10, or negative, yeah, we'll just start by 10, so. Everything by 10 gives me -2 minus I, and that's what we got. Y'all okay with those? Okay, like I said, I squareds are the one that you're gonna see the most often, like as far as like when we're working in problems and stuff, it's gonna be an I squared, you're not gonna see a lot of powers of I that you're gonna deal with. Alright, so, we're kinda back at looking at when we have these negative radicals. Alright, so yesterday when we looked at radicals, the easiest way to deal with things was to multiply them together first, then simplify the radical. I still believe that's the best way to do it. So if I multiply -15 times a -5, I'm gonna get positive 75. So square root of 75. Oh, you know what? You can't do it that way. No, we gotta you have to take the I out first. I'm sorry. We do have to take the I out. Sorry. So I square root of 15 times I square root of 5, sorry. We have to take it out first. Alright, so now I have I square root of 75. I stays out here, this splits to be 25 and 3. Square root of 25 is 5. Oh, that's I squared, I squared, sorry, I squared. Alright, so we've got the I squared out there, then we're gonna put the 5 with it, so essentially we would have 5I squared, square root of 3. I squared becomes a -1, so -5 square root of 3. Yeah, we'll have to take that I out first. Y'all okay there? Alright, let's look at 23, I'll do the same, I'm gonna take the I out, 2I square root of 10 times -3I square root of 2 put those together, that's negative 6i squared, square root of 20, which is 4 and 5. Square root of 4 is 2. Is 6i squared, we could probably go ahead and deal with that right there. That's a negative 1 times the negative 6. So it becomes a positive 6 right there. Feel okay with that? Alright, then I've got 6 times 2 is 12, so 12 square root of 5.
I love this.
And you could wait and do the i's, the negative, or the I squared and change it to the negative at the very end if you wanted to. That's really just kind of a preference thing. I try to get rid of them as soon as I possibly can. Y'all okay there? Questions on those? Do you wanna look at 24 and 25, or you want me to just jump to 25?
Jump to 25.
25.
Okay, I was like, 'cause 25 looks a little uglier.
It does.
Alright, so here, I've got my negative 4 is gonna stay, this I has to come out of this, right? Okay, so I've got negative 4i square root of 6. And I'm gonna go ahead and you can simplify that if you want. Y'all wanna simplify it there or wait till the end? I'm gonna end up multiplying anyway, so I think I'll wait. Y'all okay there? 7 minus 3 squared. Okay, so now I have to multiply this times both of these things. Y'all okay? Alright, so negative 4i basically times the 7 because radical's gonna stay. That's gonna be negative 28i square root of 6. Can't really do anything with that. When I multiply this, my negative 4 times my negative 3 is gonna give me positive 12i square root of 72. Y'all okay there?
Wait, what'd you just do?
I multiplied this right here, negative 4i square root of 6, times negative 3 square root of 12.
Oh, okay.
So I multiplied the negative 4 with the negative 3, or the negative 4i with the negative 3, got 12, positive 12i, and then the 6 with the 12 there.
Alright.
Does that make sense?
Let's get that.
Okay, which gave me 72. This I can't do anything with. This, 72 is gonna be 36 and 2. And that's gonna be a 6 right there. And there's really not gonna be anything I'm gonna be able to do with any of that. So the negative 28 I squared of 6 is gonna stay. 12 times 6 is 72 and it's positive, so plus 72 I square root of 2. And there's nothing else that can be done, like, because those radicals are different.
Yeah.
There's not a 6 on. So 7 to your I.
Times 12. 12 times 6. Okay. You got it? You good? Okay. Alright, so let's take a look at these two, because they're kind of messy. I mean, they're not terrible, but. Alright, so we're gonna FOIL this, so we've got 3 times negative 8, negative 24, and then I've got 3 times 2 square root negative 3. This I is gonna come out of this. Are y'all okay? I know that that's gonna be an I right there
Yes.
without me having to write it.
Yes.
Okay, so when I multiply that, that's gonna give me 6i square root of 3. Are y'all okay with that? Okay, plus 6i square root of 3. Everybody understands where that came from? Yes?
Yes.
Okay, then this one, I'm also gonna have an I that comes out of this. Like that right there is gonna give me an I, and that right there is gonna give me an I. Like I already know it, so rather than do it in 2 separate steps, I'm doing it at the same time. Y'all good? Okay, so I basically got negative I square root of 3 times a negative 8.
So it'd be 8i.
8i square root of 3. Are we okay there? I'm just doing it in less steps. If you needed to write the steps out, we can. I don't care. I was just making sure we kind of understood. Alright, so then I have, this is gonna be I square root of 3, right? And you could write it there if you wanted to, I square root of 3. And this one would be 2i square root of 3. That's really kind of what that is. Are y'all all right there that that's what they are? Okay, so I'm multiplying, negative I square root of 3, because there's a subtraction in front of there, times positive 2i squared of 3. So that's gonna be 2, oh my gosh, that's kind of a mess. Alright, so I've got the 2i times a negative I, which is gonna be negative 2i, right? two I squared actually. Two I squared because I had i's in both places. Are we okay there? I also had square root of 3 times the square root of 3, which is 3 there. Are y'all alright with that? All that'll have to get smushed together. Are y'all alright with how I got all that? Okay, so I had this negative 2i squared. That I squared is a negative 1, right? That right there is a negative 1 times the negative 2 is positive 2, right? Yes? Times 3. So we got 6 back there. Y'all okay that this whole thing back there becomes a 6? Yes? Do we need to go back through it again?
No, we got that part.
You're sure?
Yep.
Okay.
Yeah, I know.
So I've got negative 24 and 6, negative 18, and then 6i and 8i square root of 3, so plus 14i square root 3.
Wait, where'd you get 18 from?
Negative 24 and the positive 6 back here.
Okay.
Y'all good? You're sure? Okay. So that one's finished. Alright. So this one, we're gonna we're gonna write that again and we're gonna FOIL it out. So I'm just gonna write it back here, y'all, okay there? Got that. Alright. So, oh, that's a square, that's a negative 2 underneath there, sorry. Negative 2.
Me too.
Alright, so I think it might be best for me to rewrite that. I probably should have done that a while ago. So I'm gonna rewrite them. So I've got negative 4i square root of 2 plus 1. Good there? Here I'm gonna have basically the same thing. Negative 4i square root of 2 plus 1. Now I don't have to kind of do the sign changes and stuff in my head like we did over there. This is probably a little bit easier. Alright, so negative 4i square root of 2 times negative 4i square root of 2. Alright, negative 4 is gonna give me 16, right? So I'm gonna kind of write this way. I've got 16 I squared, and then the square root of 2 times the square root of 2 is just 2. So basically that whole first piece gives me that right there, which we'll simplify in a second. Are y'all okay with that? Alright, then this is gonna be minus 4i square root of 2 back here, and this is also gonna be minus 4i square root of 2, which would be negative 8i square root of 2. Are we good there? Yes or no?
Yes.
Y'all good? Same?
I think so.
Because I'm multiplying this times 1, and I have it twice, so negative 8i
Oh, okay, yeah, I see where.
square root of 2. Since it's times 1, like,
Uh-huh.
we should be okay. And it's the same thing, because it's a perfect square triangle. Y'all all right there?
Mm-hmm.
And then at the back, I'll just have plus 1. Alright, so this right here, my I squared becomes negative 1, right? So 16 times negative 1 is negative 16, times 2 would be negative 32. And a positive 1 gives me negative 31. And then minus 8i squared root of 2.
I love that.
Yeah, that one was bad, yeah.
I was
Do
really
what?
mad. I was
That
really
one was better